So we can even handle more than two masses. This says find the acceleration and then find the tension in both chords. There are two ropes, so there's going to be two different tensions. Jada, what does part A want me to find?
Acceleration.
Any suggestions on how I might want to start out? Good. I tend to go from left to right, so let's start with the 1 kilogram mass. Jada, what are the forces acting on it? Get the obvious one. Is there more than one mass in this question? Nod your head. I'm going to call this, instead of just mg, m1g. And make sure, develop that habit. If there's more than one mass, use little subscripted numbers. Otherwise, you might get them mixed up later on. What else?
Normal.
Is it sitting on a surface? So is there a normal force? Good. You would have caught that. What else? I'll give you a hint. You're feeling it right now.
Tension.
Little tension. Which way? Is there more than one rope? Then, you know what? I'm going to call this side tension A. I'll call the other rope tension B. You could call it tension L for left side and tension R for right side. You could call it tension 1, tension 2, tension alpha, tension beta. Just distinguish them. I'm going to jump over here to M3 because, Jada, it's the next easiest. What are the forces acting on mass number 3? Get the obvious one.
Gravity.
What else? Tension, different tension. I'll call this tension B. This middle mass is going to be a bit cluttered, but that's okay. Let's go systematically. I'll call this mass number 2. What are the forces acting on it? Yep. M2G down. Is this one sitting on a surface? Normal force, same size as M2G down. I'll call it normal force number 2 to go with mass number 2. Forces come in pairs, and so I am going to have tension B. In fact, tension B is what's moving mass 2 and mass 1 forward. Actually, mass 2 forwards. Okay. Ooh, forces come in. So, tension A. We're missing one more. Can you see it? I heard it whispered. There's a coefficient of friction. Now, these two aren't sitting on a surface. No friction. Here, friction. Which way? Which way is this mass sliding? Now we're going to have to do some thinking. How big is this mass? How big is this mass? The 8's going down, the 1's going up. There's no way the 1's going to pull up the 8. So if this is accelerating at all, friction is this way. Jada, I'm going to call it friction force 2 to go with mass number 2. Can you see if we had more masses and more strength, we could just continue. It would be a longer free body diagram, and it's going to be a longer equation. But here we go. Which way is winning? I think, Jada, if you'll agree with me, we're accelerating that way. So anything that ends up pointing down once it gets to here is going to be winner plus. Anything that ends up pointing up once it gets to here, going to be loser minus. So, who's winning? More specific, because there's 3 of them. Good. You've just decided what our winner is, and now we're going to walk along the rope. So, walking along the rope, who's the loser? Ruby, did you see it? I said, who's the loser? She looked at you. Oh, wow. Fine. Who's the losing force? And that's going to be loser minus. Then if I follow this, follow it, it ends up pointing down. So this tension B ends up being winner plus. What about this tension A here? Follow it. I think when it gets over here, it'll be pointing up. So loser minus. What about friction force number 2? Also loser minus. Now, this tension A, you might be tempted to say, well, it's pointing up, so just the same way that this one was pointing up, it's a loser. But if you follow it, I think when it gets over here, it's pointing down. It's actually winner plus. And same with this M1G. You might be really tempted to say, well, it's down, so it's a winner like M3G. But if you follow it with your eyes, when it gets to this side, it ends up pointing up. It's a loser minus. And for the 4 of you that were away on Friday, here is the tweak. It's no longer what, MA. Instead, Sadie, do I have forces from more than one mass on the left? Say yes. Then I have to have more than one mass on the right. It's going to be M all A. That's the tweak. Josh is yawning. Josh, put your pencil down. Stretch it out. Come on, you need it. Everybody, stretch it out. Why? Oh, this is even better. Jada, why can we really stretch here? Oh, I'm losing tension there, and I'm losing tension there. These are like little spa treatments. Oh. Love it when we lose tension. What's part A asking me to find? How would I get the A by itself? Instead of cancel, I'm looking for a word that starts with the letter D. Yeah, that's really what we're saying is divide. And what we mean by M all is M1 plus M2 plus M3. Is it last block? You feeling a little adventurous? Let's see if we can go straight to numbers. I would never do it this way on a test. I might write out a bit more, but let's see if we can go straight to plug and chug. So A equals, I see M3. How big is M3 exactly as a number?
8.
Yep. G, 9.8. Cancel, cancel, cancel. Oh, minus, Bryce, friction is what times what? Good. Jada, what's mu? I don't know. What's mu with you? Shut up. Yeah, sorry? 0.25. Are you going to use that joke every time? Probably. Times the normal, I don't know the normal force. Oh, but look, which, it's going to be M2. How big is M2?
9.
Yeah. Times 9.8. Okay, and I'm going. Oh, then I have minus M1, 1 times 9.8 all over 1 plus 9 plus 8. If you are comfortable doing it like that in your homework, Jada, I'm fine with that. Probably on a test, I would have written out the mu times the normal force, one more line, and then done the substitution. But maybe not. Get out your calculators. I would encourage all of you, every one of you, to try typing this in on your calculators to see if you can. Thank you so much. Definitely brackets around the top. Definitely brackets around the bottom. Quick like it, buddy, please. Hustle back. Built-in error check. Jada, if I cut the rope, what's the biggest the acceleration can be? 9.8. It's getting slowed down. You're going to get an answer less than 9.8. I don't know what, but less than 9.8. What'd you get? 2.58. Anyone else? I know I'm going to be using this. Is it 2.58?
2.5.
2.59? Can you give me, actually, Jada, give it to me to 5 sig figs first. So what? 2.586. Okay, now I'm going to write 2.59, but I have a feeling I'm going to be using this, so I kept a few extra sig figs. Well done. Okay, Ruby, part B says find the tensions. I want to do this as quick as possible. Which mass would I not use to find tensions? I'm running away from the middle one. I can do it, but why? So, Ruby, can you first of all write me an equation for the left-hand mass, mass number 1? Who's winning, who's losing equals M1A. How do you know T is winning? It's up. It's accelerating up. So it's going to be tension A minus M1G equals M1A. How would I get the T by itself? It's going to be M1A plus M1G. Let's see if we can go straight to our calculator without even writing out the numbers. On a test, write out the numbers, because that way if you make a calculator mistake, I can still give you almost all the marks. Generally, if you've written everything correctly, but your answer is wrong, I take only a half mark off, because I assume you made a typo. So it's going to be 1 times 2.59 plus 1 times... Oh, I can do that in my head. Is it 12.39? 12.4? I can do math in my head. It's the 1 times table, right? Finley, even you could do... Yeah, okay. 12.4 newtons. Cool. Hey, Finley, what would the equation be for the mass 3 right-hand math?
Gravity.
Which one?
Gravity.
Which one? M3G minus tension B M3A. How would I get the what's right in front of the T that I don't like? So we nicknamed this the Swappy Dance. We said, you know what? You can plus that there at the same time subtracting that there, and we get M3G minus M3A, and then we decided let's put the T equals on that side. This is where, because now you no longer have the answer button stored, this is where I would use the 2.5861. Now let's, again, try going straight to numbers. Finley's looking like he did it already. What'd you get?
57.7.
57.7, is he right? Newtons. So, Diego, am I going to give you a 3-mass problem on your test? No. Maybe a bonus, but not as an actual question. But you can see also, did we do anything new there? It was longer, a little more cluttered, but I don't think I taught you anything new. Oh, if there's 2 ropes, 2 tensions, label them differently. Don't put T's everywhere because you might get them mixed up. What's your homework? I already assigned it last day, but for those of you that were away last day, 1, 3, 5, 6, 7. But I crossed out 8 last day. You can add number 8. Here's your 3-mass problem to try in your homework. 9, 10, 12 was the nasty scholarship question for you to try. There is 27 minutes left. I might interrupt the class near the end and go on a rant, but I might save that for another day. Depends on how well you all are working.